Hello, greetings. Hassan Badru. I'm doing a modification of the counter from 0.0 to 9.9. Pretty much there's no difference with the configuration and there's no difference with design. The only difference with the code I wrote, I just made this shorter using a loop function, using a loop, yeah. And this didn't take up to half of the amount of lines of code I used in the initial implementation. This counts, let me reset it, counts from 0.0 to 9.9. Pretty much the same thing we did before, the right side and the left side. So so we're going to use knowledge from the previous demo we did to understand this. Okay, I'm not going to wait till it counts, till it's done counting. I want to go real quick over the code. I use a Linux OS pretty much. I'm about to sign into my computer. Okay, so pretty much what I did was that I use loops. Okay, now let me go over the matrix. I use a loop to. Okay, in this situation, I'm going to use a 10 by 4 matrix. The first thing I did for this matrix was to populate the matrix with these numbers, with these values. So I populated the matrix. So this is for the matrix row 0 is for number 0, row 1 is for number 1, row 2 is for number 2, row 3 is for number 3 to row 9. And then the columns. Column 0 means pin 0. Column 1 means pin 1. Column 2 means pin 2. Column 3 means pin 3. And I created them in a 10 by 4 matrix. Okay. Then I use a loop. I use a loop to count. Since we have 10 rows, I counted from 0 to 10 with an increment of 1. Then within that loop, I created a nested loop. So, and the second nested loop is going to be for the column, which also represents the pins used, and this is going to count from 0 to 4. So within that function, within the loop, the second loop is going to count from 0 to 4, while the value of row is the same. So for instance, the value of row equals to 0. While the value of row equals to 0, that's for number 0, it's going to count. So it's going to whatever. So I use a digital write, and the pin is going to be the pin of the value of column. So if column is 0, I'm going to have 0. Then it's going to give me the value at matrix 0 when row is 0 and column is 0. Then it's going to run it again, and this time around, because it's increment, so the column will be equal to 1. So at pin 1 is going to put in the value for 1 at 0 at row 0. Same thing is going to do for column 2. The value increases to 2. For pin 2, column 2, it's going to put the value that exists there. So it continues on and on. So when it executes till column is equals or greater than 4, it's going to exit the loop and come into the initial loop, and it's going to increment row. Row is going to go to 1. When row goes to 1, this runs again. Same thing over and over again. That's what happens, and we're able to get the value on 7-segment display. This is a typical code for servers to display numbers from 0 to 9 on a 7-segment display, and this is for 4 bits. So now I'm going to use my computer to talk about how I was able to come about the decimal place, and I was able to make the program run simultaneously. The two 7-segment displays, I was able to get them to run simultaneously. Now I use a trick. I created a loop, right, that to get the actual value for the integer part. So this gives me the value for the integer part. As you can see, then the main loop, I get value for the integer part. So this is the integer part. but within the loop, before it moves to the next number, that before it moves to the next row, so this is going to be within the first loop, I call a function, and this is the function I created for the second one, the second bit, the second 7-segment display, which stands for the fractional part. Okay, so this function bit is pretty much the same as the first function, just that I changed the pins. So the row is the same because I'm trying to get values from 0 to 9, right? Then the column just changes because I'm using different pins. So if you notice, okay, my screen is my camera, I don't know why I'm having a blurry image, but as soon as it gets back I'm gonna show it to you. But let me just go on. So pretty much what I did here was that I used the columns as the pins. So the same thing that happened there, that's what happened here, just that in this situation I'm waiting for the image to come back, but I don't know why it's blurry. Okay, but I guess you should be able to understand what I did here, right? So yeah, it's clear again. So this now for me to, this is supposed to be -4, but I started my pin from pin 1, pin 2, pin 3, pin 4. So in this situation where you have -4, -5 is supposed to be -4, right? It counts from 5 to 8. This is my code, counts from 5 to 8. And when it counts from 5 to 8, give me the value there. But I'm trying to get the value at colon because we are not changing the matrix. It's pretty much the same matrix we're using. But the matrix doesn't contain colon 4, 5, 6, 7, 8. So for that reason, we notice that. For that reason, we notice that this colon is the same thing as colon 0 is the same thing as colon 4. The same thing as colon 5. The same thing as colon 6. Same thing as colon 7. So what is common between these two values? The difference between these two is 4. Difference between these two is 4. Difference between these two is 4. So what I'm going to do is that I'm going to, because I'm trying to get the value here, so all I have to do would be to call the function matrix at the value of row, which is the same, 0 to 9, as you can see. Then I call the function colon -4. Let me erase this so you can see why I wrote properly. So this is what you are going to get. Let me write it properly. -4. So that's pretty much what you're going to use, and you get the same value for 0, 1, 2, 3, 4 because we're pretty much counting the same number. But I use this for the second LED. But it's going, instead of output a number on colon 0 this time around, it's going to output a number on colon, which is going to be in this situation, which is going to be 4, right? So it's going to output it on pin 4. It's going to output the value of 0 on pin 4, value of 1 on pin 5, value of 2 on pin 6, value of 3 on pin 7. So that explains how I was able to make my program so short. And as you can see, this is all the program is. It's not more than this. This is compared to the previous program I wrote. And also for initializing, I was able to, for initializing and for initializing the pins and what I put to use, I use the loop 2 that counted from 1 to 13, which is the maximum pin I'm going to use. Then I declare the pin modes, all the pin modes as output. That's pretty much easy. And something I like to warn you all about: when you're writing your code within this main loop, when you're trying to call the function for the second LED, which I named counter, you would need to put the argument. And I repeat, you need to put the argument row. See, I declare the argument because it returns that value. Although this is a void loop, so it doesn't return any value, but you need to put the argument in it, and then you need to use a continue instruction. This makes the program continue. This makes the program exit that loop, and it makes the program continue run. It makes the program continue running that loop until the condition is not true, then it exits. So I hope you're able to understand what my explanation from this demo. Thank you so much, and thank you for listening, and I wish you a great one. Hassan Badru.